Awesome. Thank you very much. And thank you everyone for attending. I have added kind of auto captions, so they will hopefully be useful, but might be a little off at times. And also for Q&A, for questions, there is a URL at the top that will collect questions from everybody, and I will answer those at the end. So please toss in anything you like there, and we'll try to make this take advantage of the interactivity a little bit. So yeah, so the context here is where should I run my stuff? And this is stuff in this case, like technical term, right? But for any kind of software. And when you're looking at any cloud and Google's cloud, you see there's so many different ways to do similar things. And I think it can get a little overwhelming. So this is a talk to kind of talk through the different options and the trade-offs between them. And I'm going to kind of do a whirlwind tour of all the different hosting environments for running software. So let's get to it. Short version is, it depends. Like all good technology conversations, it depends on context. It depends kind of what your needs are, what you're trying to do, what your team is like, what your short-term and long-term goals are, all kinds of stuff. So we're going to get into a bunch of that and see what we have. So for a little bit of context, kind of grounding on Google Cloud as a whole, for our compute options, I like to think about it as kind of a layer cake. And things at the top are much more abstract. And then things at the bottom are much more concrete. So at the bottom are VMs. And the summary of this slide, or this talk, is basically on this slide, and kind of with a best fit recommendation for each of the kinds of things. And getting oriented to this stuff is a little overwhelming. There's all these kind of proper nouns and new words and such. But basically, Compute Engine is virtual machines. Kubernetes Engine is hosted Kubernetes for running large sets of containers. Cloud Run is this, we want like serverless-like behavior, but for anything that can run in a container. App Engine is for entire kind of web applications. And Cloud Functions is just the function part of software. And usually we use it to kind of do small bits of logic from an event that happens in the world somehow. So there's some kind of buzzwordy stuff that's kind of unavoidable in some of these talks, containers and serverless and the like. For the purposes of this talk, when I'm talking serverless, I'm primarily thinking about the operations model where you do not need to specifically manage the particular bits of hardware or even the kind of execution environment for that code. That's handled for you. It scales up and down. And this key kind of idea of the auto scaling portion of it. And there's some more nuance to it, but the takeaway for most folks is that you pay for only exactly what you use. And as we're kind of approaching this question of kind of where to run stuff, I'll get more concrete about this at the end of the talk, but I'm going to make the claim that there aren't as many risks in this decision as it might seem like. Basically the short version is if you or I can get into containers, you have the full set of choices to choose from, and you can easily move up and down when you do that. Okay, so we're going to kind of run through these kind of top to bottom, and then talk about what each of them are, and then actually talk about the trade-offs. That said, this whole talk is in the context of the day, so I'm going to go light on the top portions and a little heavier on the VM section in my talk, because we have talks this afternoon that are talking about serverless as a whole from Martin and diving deep on the Knative Cloud Run Kubernetes side of things from Mete. So I'll go a little lighter on those and a little deeper and do a kind of an interactive demo on the virtual machines, the Compute Engine part. So Cloud Functions, kind of start at the top here. What is it? So it's a serverless environment to build and connect cloud services. It is, if you're familiar with AWS, Lambda kind of functions. It is a core individual function, part of code. You write the name of it, what inputs it takes, and what outputs it has. And that's the whole thing. So your function takes some input and returns something. Maybe it has some side effects. It does something to the rest of the system. This is incredibly useful for gluing pieces together. When you're trying to make different parts of things like behave like one system, very useful there. It's usually driven by some sort of activity in the rest of the system. Not really usually used for long-running jobs that are autonomous and kind of do their own thing. So you might get a message in from something like PubSub, or a new file uploaded to cloud storage, or a web request comes in, things like that. And it is full-on serverless. It's fully managed. You pay for only what you use, auto scales, all that kind of good stuff. And when you're using Cloud Functions, you're thinking in terms of events and the function definitions. That's what you've got. Most of this is a relatively new technology in the last few years. So most of the times it's going to be new code written. It's a really good fit when you want to be serverless, you're event driven, kind of don't want to or think about the runtime environment. It's one not obvious thing is kind of in the ETL, kind of enterprise, extract, transform, load, the kind of data processing world. So transformations of data is really useful. And I like to think about it as just glue. It's the stuff that binds our systems together. On the constraint side, it is a function level granularity. You're always thinking in terms of functions, and everything interacts via an event that happens. The functions can't start themselves, and it only supports particular language runtimes. There's about 4 different languages that you have to write in. You'd choose it because you don't have to think about serverless servers at all, the hosting environment, the granularity of payment, and this very simple developer experience. You write the thing and it works. Okay, next up, App Engine. So we're gonna kind of go one layer down the abstraction. One way to think about it is this is a whole set of functions together to create a whole application, a web app. So still, it's serverless. Arguably, the serverless OG, it's been around for over 10 years at this point. Scales down to 0. It's very mature, robust. Lots of different tools around versioning, traffic splitting, things like that. What you might not know if you're familiar with App Engine from 10 years ago is that the new runtimes are open source. They're container based. You can actually run any code that runs in these languages. So a lot of languages have kind of bindings in C. It used to be that App Engine could only run the kind of native to the language things, and now you can have add-ons or kind of what have you. And it hits the regular Google Cloud APIs directly, rather than kind of the original App Engine specific APIs. When you're writing an App Engine, you're thinking in terms of kind of a code base and URL handlers, so the web requests that are going to come in and what you want to do when each of those requests come in. And then for your whole app, you deploy a version, and you can say, okay, I want a new version. Oh, that didn't work out. I want to roll back, or I want to give 10% of the traffic to the new version, things like that. It's a really good fit for web applications. Anything HTTP, HTTPS, request response applications, or kind of either stateless backend, or if you're using it connected with our data store scalable kind of state in the backend as well. It's really good at scaling both up and down very quickly. So one of the very common use cases is in advertising websites, where they're very, very quiet until an ad hits TV somewhere, and then spikes up to who knows how many ads if it gets on a big, or a mention on a big news organization or something, and then drops back down. So it's good for that sort of thing. On the constraints, again, there's a set of runtimes that are supported, language runtimes. So if you're writing in those languages, great. If not, it's not a great fit. And the only way to talk to the apps is actually through web, through HTTP. So if you need to be, answering SIP phone calls or something like that, this isn't the right place to do it. You choose it because you're a developer team and you want to focus on your code and have the rest of it handled for you. It's just a really great fit for web workloads, especially variable. And just as a note, it gets a huge amount of traffic across tons of customer sites and Google sites, and you're very unlikely to kind of overrun it. So give it a go if that's what you want to be doing. Next up, kind of down into the middle, we're looking at Cloud Run. And Cloud Run is where we kind of hit this bridging of the serverless space and the wider container space, and kind of the more details, and where you start to get at the infrastructure. So what it is it's actually a Docker container image. You can give it one off, a URL to a Docker repository, or you can build using our build software. And you have a little code base, and it can be anything that can listen to on a socket for web requests that come in and respond however it likes. So you can write an app in Fortran, COBOL. We have fun examples of doing that. Or kind of any language you've already got running, or anything else that can live in a Docker container. It automatically handles a lot of the complexity for you, though. So it handles SSL termination, the connecting the web request to containers, that kind of glue. One thing that's especially powerful for kind of bigger, beefier, more robust apps is, if your code base can handle more than one request at a time, this is much more cost-effective place to run the software. So a lot of Java apps fit in this kind of scenario, because you can handle up to 80 concurrent requests at the same time, and you're only paying for the instance as it's running, even if it's handling multiple requests. And again, it scales all the way down to 0, and you pay for only what you're using. So that's great. In addition, you can also run this same environment on top of Kubernetes. So if you're a shop that is already heavily invested in running Kubernetes on your own machines, or using it as a tool to insulate you from different cloud environments, this is a way to get your developers a serverless-like experience. So if you're on the platform team for an organization and you're trying to give people, your developers, a better experience, or they're clamoring for a smoother developer experience, this is a way you can give that scale up, scale down, auto handling the routing and the like, but keep it within a Kubernetes cluster. So you can basically take a Cloud Run image and deploy it either to our dedicated hosted service, or to Knative and a few other bits running on top of Kubernetes, and get the same environment. So basically you got this kind of write once, run in a couple different environments option. So when you're using Cloud Run, you're thinking about the code that lives in the image, this contract of kind of listen on a port, handle the web requests, and respond. And it's up to you to figure out how to build that image. So if you already have it, great. Or if you want to use our build tools, you can do that. Or if you've got some other way, if you want to just build it on your development machine, you can do that as well. That's kind of part of the, you have to decide what you're going to do there. Whereas at the higher levels, that's just all handled. You give it the code and go. The other piece that I think is concrete is the like most running containers, the local state doesn't persist past shutting the process down. So your application needs to, if it has longer running state, it needs to put that in a database or in some sort of external storage for that to work. So that's one of the constraints, no local storage. Another constraint is that it has to be running in a container, in a Docker image, Docker container. So if your code fits that kind of environment, you can get basically all of the serverless advantages. So it's a good fit for things that don't have local state, for web request response stuff, and then especially where you get into needing a very particular language, certain dependencies. You've got certain company goals for like how you want to have your images built or the security checked on them, you can kind of do all of those policies and still get serverless experience. So that serverless experience is the main reason you choose this. And then you have the option of integrating it with a Kubernetes cluster or not. And you can even actually run these same images on a local machine. And Knative is the open source project that we run on top of when we're doing that from Kubernetes. So I just wanted to highlight that. And yeah, so that's the high level there is, get a container to serverless in seconds. It is serverless and kind of keep that consistent experience. And then just wanted to highlight later today, Mete's talk will be all about Knative and Cloud Run. So you get much more concrete and examples of what that looks like to really do in his talk later. And next level down the stack, take a moment, is our hosted version of Kubernetes. And I think at this point, we can say Kubernetes is kind of a de facto or kind of standard, most common environment for managing large sets of computers to run containers. And at a high level, it lets you treat these whole sets of computers as one compute environment. And you can say, hey, compute environment, I want to run 3 copies of this web container and 2 copies of this backend processing container. Just go decide where those run, make sure they keep running. If something goes wrong with that process or with one of the hosts it's on, restart things to make sure that they're always running. And that's what it handles for you. But backing up a bit, why containers as a whole? I think this is it's kind of in the air now, but I like to think of it as it solves the works on my machine problem, which is where, you've got, some development that happens and everything works fine. And then you go to a different environment to production or, a different production environment and things behave differently because the dependencies are different or what have you. So the container is this kind of set of files that make up the program to make sure that you get the same environment every time you run it. And then Kubernetes itself is, like I said, this whole cluster management thing. And then Kubernetes engine manages all of the cluster itself so that you can really focus on just the configuration and what you want to do. It sets up the different compute nodes, handles software updates on them, runs the master that you're talking to for API server. When new versions come out, it handles the upgrades. And since it's running, these nodes are actually virtual machines in the cloud. So you can actually make the cluster itself larger or smaller automatically, depending upon the overall usage inside the cluster. So that can save a bunch of money. And then also, when you do have a heavy load, make sure you can respond to it. So when you're working in Kubernetes, you're thinking about what I like to think of as logical infrastructure. So it's not too far different from when you get together, with colleagues in front of a whiteboard or virtual whiteboard maybe these days, and are saying, okay, well, here's this part of the system and it talks to this and that talks there, and here's how the pieces connect. And you're making configuration files in YAML that are at that level of abstraction. You're saying, hey, I want this set of containers that do this, and they should, be available at this service name. Other containers in the system can use that name to find them. They don't have to know which machines they're on or how the network is configured and that sort of thing. And this gives you some insulation from the other, parts of gives you some insulation from the environment you're running in. So you can take this same set of definition files and spin up a cluster that runs that system on your own machines, on a cloud, on Google Cloud, or like a test and dev and prod version of environments, that sort of thing, and have it be the same. So yeah, you're thinking about the applications, how they connect. So this is a really good fit for this kind of installation thing. When you've got an app that needs to run multiple environments, there's a lot of folks who, for data locality reasons, need to run separate versions of the system. It's the same code base, but for regional legal reasons, you need to run a separate copy that never leaves one space, that sort of thing. And when you're all in on containers, Kubernetes gives you the flexibility to connect them up the way you want them to be. I do think it's important to note that this implies that you've got pretty good communication between your developers, your operations folks, your security folks, and that everyone is able to make changes to the builds for these images, so that if, for example, there's a security patch that comes out, that can be checked in and run through the same build process that the developers are using to add features, and rolled out and operated the same way. So I think that's important. So you will very likely want some sort of continuous integration tooling to take full advantage of this. And this is the first place in the stack we've talked about so far that you can kind of natively handle any sort of network connectivity that comes in on a socket. So if you need to handle particular other network protocols and the like in your software, this is the space where you can start doing that. On the constraint side, this is container focused, so your software has to be running in containers. And the licensing is something you have to be a little careful with. By default, like, the software is moved around everywhere in the pool. So if that works for the licensing of the software you're running, great. If not, there are some features to kind of pin different pods, which is where the containers run, to certain machines. But things do get more complex there. And at a high level, why would you choose these? So Kubernetes as a whole, I think this insulation is a key bit. It enables high utilization, so cost savings. The core, I think the core motivation that Google got highly invested in containers early on, made some of the initial patches to the Linux kernel to enable this sort of C groups kind of separation of processes, was specifically so we could safely run lots of different software on the same hosts. So the containers and Kubernetes allow you to push the hardware you're running things on much harder and have all the software keep working well, which means that you get more out of the machines you've bought or that you're renting in the cloud. So this is a core reason why people consider Kubernetes. And it's also an abstraction kind of sweet spot, I think, for a lot of folks. You get to reason about your system at kind of an application layer that with enough depth and complexity to let you do the things you need to do, but keep you just a little bit insulated from things. And then Kubernetes engine itself is all of those features, plus you don't have to worry about the cluster itself. It's run for you, managed, the networking's all configured, and depending upon the case, that can be fairly tedious or time-consuming, challenging to get all the pieces right before you can run the app. So if you are new to the Kubernetes space and you just want to try it out and see if it matters to you, if it works for you, then I'd highly recommend, wherever you plan on running it long-term, to give it a try in a hosted environment like Kubernetes Engine, because that lets you focus on learning how it works, and then you can decide whether that model actually makes sense for you and your team and your company. And then if it does, you can look into either running it there or running it in other places. And then next down the stack are our VMs. So the VMs are called Compute Engine. And I like to think about them as this slice of a data center. So if you saw Greg's talk, heard that phrase before, and we're going to go into this in a little more detail. So initially, though, they are just virtual machines. So if you're familiar with VMware or other tooling, a lot of things will feel similar, right? You have settings for how many virtual, or slices of CPU you get, how much memory, how much disk, and the like. And Google Cloud takes that to a very, very granular degree. So on our general purpose VMs, you can move the sliders around between number of CPUs, the amount of memory, the amount of disk, how many GPUs or TPUs you have connected to it independently for the workload you have for that machine. So, a database machine might have a ton of memory. A kind of rendering machine might have a ton of CPU. A web, box might have a little more balance. Whatever is the right fit for the workload you have. And at any point that you are a reboot away from changing all of these things. So if you don't need to overbuy, and if it turns out you need more later, you can just reboot and make that box bigger without having to re-architect anything. And then for certain specialized use cases, things like running SAP HANA, which is a large in-memory database, if you just need tons of RAM or lots and lots of CPUs, you can get those available. And our largest machines are up to 12 terabytes of RAM now. And, for context, I was shopping for a new hard drive recently, and the largest ones that I saw were not that much bigger than that, something like 16 terabytes. So we're talking about machines with as much memory as most people have hard drive space. And so, yeah, your limits are pretty high and far out there in this space. They also, they start very quickly. So about 30 seconds to get from, clicking the button or hitting the API to start a machine to where it's running. The OS is booted, like it's all provisioned, the OS is booted, and it's already running user code on the image. And so that, helps with scaling or tuning systems. And we have pre-built images from a large variety of operating systems, both open source and licensed. Or I guess all things are licensed, but free licenses versus commercial licenses. And those images have some tooling built in to kind of make things a little smoother in Google Cloud, things that look at this local metadata server, for example, to make authorization easier and the like, or kind of push logging to our central logging service called Stackdriver. But those are optional, and if you have images that you are running in other environments, there's tooling for importing images from other virtual environments or creating an image from physical machines. I want to dig a little bit on the disks, and so this is where the machines being a slice of a data center versus a slice of a particular computer are kind of most evident. And so you can attach and remove various numbers of disks to the machines while they're live. You can even resize the disk that's already attached and make it larger while it's currently running. And then if your OS supports it, and most do, you can then resize the partition and suddenly have more space available. So I think nearly all of us have had a system that's run out of space, and you're trying to figure out how to troubleshoot it and the like. And so you can kind of poke at it from the outside and say, okay, make the data disk bigger. And now that things are back up, let's go investigate why that got full at all. So that's very powerful. Things like for IT folks who are trying to run software that already exists, and it's not going to be moved into containers. You want to keep it up. You need a little more reliability. You can do things like have these disks that are auto-replicated at the block level between two of our zones, so that even if an entire zone went down, you can start up a new VM from that disk and have it be up to date. So that's a really powerful way of getting more disaster recovery options without having to re-architect things. So you get a bunch of the advantages of the cloud without the, oh, great, and to do that, we have to rewrite all this stuff. So that's there. And I think also kind of thinking about it as kind of like most of what you get out of a SAN, you have snapshots that you can take while the machine is up and running. And those snapshots are global. And so you can create new disks and new machines from those snapshots anywhere in the world, either for testing or for scaling and the like. And if you do have a system that is kind of workers, that are each running on their own machines that are pretty similar. They like talk to a queue or get traffic in from a load balancer. You can set up auto scaling groups and that are based on these snapshots to create new disks. And then if you do have really low latency, high throughput needs, our default disks are network attached and they're quite quick. But there are cases where you need to push that even further, especially sometimes for databases and the like. And we do also have local SSDs available if you need to. And then I kind of hinted at it before with the auto scaling, but these are more than kind of just VMs. So for example, we have these managed instance groups, which give you a whole bunch of things. So the managed instance group is basically a template. You say, okay, here's the shape of the machine, here's the disk that it should have, the disk image that it should start from, and create a pool of nearly identical machines and connect a load balancer to them. And these machines can be all in the same zone. They can be spread across zones or even across regions, globally, in fact. So that gives you kind of physical separation. It gives you the opportunity to hit lower latency versions of your service for your users if they're closer to different areas. And you can use the same infrastructure for doing kind of incremental rollouts. So you do a canary kind of thing where you upgrade one of the machines, make sure that everything's working fine there before you upgrade all the rest, things like that. And that all lives behind our load balancers. And this is another area where you're really getting a slice of a data center. This load balancer isn't a box somewhere in the machine. It's actually the same load balancing infrastructure that Google built to serve things like YouTube and Gmail. And there's a paper on it called maglev. So look up maglev if you like, but there's some clever hashing and distribution of routing information that allows the load balancer to be a logical construct that is actually implemented by a bunch of different machines in the data center at the same time. And what that means in practical terms is that there's no scaling up and down of the load balancer. When you create a load balancer, you're changing the config in our data centers, and that traffic is going to move regardless of how quickly you grow over time. So that's great. We have examples online somewhere of scaling from no requests to 1 million requests per second without having to talk to anybody or scale a load balancing host or the like, because it's all handled at the data center level. And then to kind of go the other direction, if you just want to run, if you do have a container and you want to just run that and not worry about all the rest of the Kubernetes or other pieces, we have a container optimized OS. And essentially at boot time, you give it a URL to a container, it downloads it and runs it and just runs that one thing. And that's really handy when you just need to run a thing and not worry about it. So, with VMs, you are thinking about the full collection of things, the software that you're running, the operating system it's running on, saving that to disk, the configuration of the disks. One thing I do want to mention is that when you go to evaluate this, larger disks are faster because you're getting this slice of a whole bunch of disks spread out across the data center. So you get both more storage and more bandwidth at the same time. So larger disks are faster. So you do have to think about that. You think about how much CPU, memory, disk you need, and then the connectivity between all the things. And you think about them in virtual representations of traditional terms, like firewall rules, load balancers, VPNs, and the like, to connect back to other data centers. So it is almost always the first place you start when you're talking about moving an existing system. It's, the abstraction is similar. It looks like a computer runs like a computer. So pretty much anything that's running on computers now, you can run on the virtual machines. If you do want a simple, just run a container sort of thing, it's actually a great place to do that. If you need very particular operating system versions or things that your organization has configured just perfectly, or a specific kernel that you need, that sort of thing, probably are going to need to run it in Compute Engine as a VM. You have full influence over licensing all the way down to, we can actually basically reserve an entire physical host for you. Like, and usually it doesn't make sense to do that because it reduces your flexibility, but sometimes for licensing reasons, it's the thing that makes sense. So if you have licenses that are bound to a particular host, you can actually kind of work them in with the rest of your workloads. Things like that. It's where most of the databases run. You can handle any network protocol that that works on a normal computer. I guess with one exception, UDP broadcast packets are not propagated through the network. Regular UDP is. And then constraints wise, the scaling happens at kind of the tens of seconds sort of range. So if you need to respond faster than that, you might want to look at the serverless bits. And it is kind of up to you how you want to handle software updates, things like that. Okay, so let's dig in here and poke at that. What does it really look like? So this is, I think, the first time today we're actually looking at the real web interface for Google Cloud, and it starts up with this kind of dashboard overview of things. And this button here, this like 3 labels, is what people sometimes call a hamburger menu, but it's the key thing to know about it. Everything is kind of buried in there. And I have pinned some things. There's a pin here to show up here, and I'm going to choose Compute Engine. And when I do that, it goes to the kind of overview. And the first thing I want to highlight is I've got a development box that has been kind of sitting here fairly idle. And we give a recommendation saying, hey, this is way underutilized. You could probably make this machine smaller and have it do the same thing it's kind of doing and save some money. So we do that across the board. And there's some options for tuning it as well. And if you click this, you can actually go through and reboot it into a smaller size. We can also just click SSH right here and open a window. Since I'm logged into the console already, it will move some generated keys over and can log in directly over the web. And then we also have a command line client that will do the same key transfer dance as well. And nothing magic here, but we can type commands in and we can do things and see scrolling text, and it's a regular SSH connection to do whatever we need to do on this box. And for Windows machines, there's an analogous option to do remote desktops, so an RDP connection to the machines. So that's there. Creating a new instance basically gives you a list of fun options, and you could choose where in the world this is going to be. I'm on the West Coast, so I'll choose a location there. We have a couple different machine types. That's where we have the general purpose versus specialized. You can choose kind of standard packages, if you will, but you can also choose custom. And this is where you can basically say, hey, actually, this is the shape machine I need, or something that looks more like this. Whatever you need to do, and do that. Down here is where you choose the different operating systems. So if we want this to be one of the other operating systems, we can do that. And just kind of want to highlight, like, all the way down here at the bottom, there is a link to the REST, which is the API call or the command line thing. And I could copy this out and run this from our G-Cloud command line tool to create exactly the same instance that we've gone through and poked at the web URL for. So this bridge is available kind of throughout the Compute Engine web interface. So you kind of use the web UI for exploration, and then if you want to do some automation, you can just basically go directly from there. And that's true either for command line tooling or the actual web request that you would make to do the same work, and a full reference and the like. So I'll kind of leave it there, but you go ahead and hit create, and that works. And what it's doing right now is getting the hardware available, choosing where we're going to run it, making our image available there, starting the actual machine, and then there's a an optional kind of boot script that you can run, which on Linux is a bash script to run some final commands or little extra things to kick off your software if you like. That gives you the opportunity to have a base image that is fairly standard and do a little bit of a special configuration if you need to change machine names or the like. And then the various different hosts, like this is, all of these are showing up in kind of one flat network environment by default. And there we go. We are now up. So this new box, if I SSH into that, it is on the same network as the dev box that I had. And if I kind of look over in the dev box now, I can ping, oops, our sizing got messed up there, but I can actually ping this new machine by name, and we do DNS setup across the board by default. And this is globally, not, these happen to be in the same zone, but that would work if the machines were in another zone entirely as well. Okay, so you'd use Compute Engine when you want to be have consistency, across the different environments, custom VMs, this live disk resizing, all that sort of stuff. And okay, so this core question: where should I run my code? We've got this abstraction stack. If you, in hearing this overview, you heard the thing you wanted automatically, or that seemed like a good fit, check that out. If not, here's a few more things. So it depends. And it depends on kind of what abstraction level you want to be, the technical requirements you have, and your team. So abstraction level is the thing we've talked about the most so far, where you're living. Technical requirements were kind of sprinkled throughout the talk, but if you need a certain kernel extension, you're going to be down at the VM level almost by definition. If you need network protocols beyond HTTPS, you're at Kubernetes or Compute Engine. And then otherwise you can be higher up. And I basically recommend, if you're starting new systems, to kind of start as high as you can and look at your technical and team requirements and then kind of work your way down as needed. And if you've got an existing system, usually you kind of start from the bottom and work your way up, Also, the billing model is a little bit different. The kind of top half is in a pay-for-use billing model, and the bottom half, basically anything running on a VM, you're reserving the VM and paying for the VM shape, and then independent of the utilization of the VM. So you want to use it heavily and kind of have the size be relatively small on those. So that may affect your planning. Your team makeup as well. If you're a team of mostly developers, you're probably going to be higher in the abstraction stack. And if you have a robust IT operations team, and you've got strong opinions about how you want things to work, you're probably going to be lower down the abstraction stack, I think. I'm going to skip a few things there. And then on this kind of making the right decision, I think for applications that work in containers, you can do that and move up and down pretty easily. And then also, I think almost all of real systems end up using them together. So you'll have things where you're using app engines with functions, or you've got VMs and some glue, in functions, or the like. There's a mix of things. Or even if you're all in on Kubernetes, that's how you want all the things to be. You still have these 3 or 4 VMs that are running, some existing software that just aren't a good fit for containers, whether that's a database or, licensing reasons or what have you. And then the thing that connects all this together is things like our pub/sub messaging, cloud storage, which is where kind of getting files back and forth, tasks, scheduler, the like. And then if you get into containers, you can kind of move up and down. And we try to give similar behavior across all these. So there's a metadata server that I mentioned briefly, and a few other things. So that's the core of the talk. Kind of coming back around to this, the sweet spot for each of these is listed here, I think. We'll be sharing all of these slides. And let's go to check out Q&A. So I didn't see any in my things, but I think we do have a couple in the Zoom section. And one of them is App Engine Flexible versus Cloud Run. What are considerations between using the two? So I actually skipped talking about App Engine Flexible. There's actually two kinds of App Engine. There's what we call standard and flex. And the standard is completely kind of hosted, managed, all at kind of the logically the container kind of level. And flex is in turn running on VMs. At this point, if you're starting a new app, I would look at running in Cloud Run because it gives you the full flexibility of kind of anything that runs in a container, scaling all the way to 0. The scaling is faster. It handles more of the routing, and it's a little newer. You know, I think the VM-based App Engine concept, I think we hit more of the goals. It's a thing we've been working on for many years. It exists, it's up, it runs, but I think the goals of it are more fully realized by Cloud Run. So if you're looking at a new app, I would look at Cloud Run. That's the question there. And let's see, any more Q&A questions kind of come through in either places? I'll give it another moment here. And then if not, we may kick over into the next section 5 minutes early.
Brian, you must have done a great job, as evidenced by several of the chat comments. Maybe you've answered everything already.
We will call it that way for now. Realistically, that can't be true. There's a lot going on here. So on this slide is some follow-up info for me, either Twitter handle, which is my full name on Twitter, or my email address at Google, which is full name @google.com. So thank you all very, very much for time and kind of these relentless set of talks. And we have more talks this afternoon from talking specifically about DevOps, so the operations of this stuff, the serverless stuff in much more detail from Martin, the Cloud Run and Knative bits from Mete, and then deep dive on AI and ML at the end of the day from Carl. So thank you all very much.